All right, welcome to Unit 6, Day 3. Today we are talking about triangle similarity. Previous lesson, we talked about polygon similarity, similarity of all polygons. Well, now we're just focusing on triangles, and we do have some shortcuts, some ways to determine if triangles are similar, just like we had when we were trying to determine if triangles were congruent. And so, because of the way triangles work, we have these shortcuts we can take. So remember, in similar polygons, corresponding angles are congruent, but corresponding sides are proportional. So the same is true for triangles. When we talked about triangle congruence, we had things like side, 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 angle, 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 side, and HL. We have some similarity theorems that also work out in the same way when we talk about triangles being similar. So here's our first way to show that triangles are similar, and it's AA, and that means angle, angle, similarity. And here's what it says. If two corresponding angles are congruent, then the triangles are similar. So we don't need all three pairs of angles. This is the only way we can use only two parts of information. If I've got two angles congruent to two other angles, then they have to be similar triangles. Because, remember, all three angles add up to 180. So if these two are congruent to these two, the third pair of angles have to be congruent also because of what we have called the third angles theorem. So all three would be the same. Whenever all the angles of one are congruent to all the angles of another, the figures have to be similar. Okay? So we can say triangle ABC is similar to triangle DEF by angle, angle, similarity. Okay? We can do another example. We have two triangles here, and we've got a right angle at W and a right angle at Z. So those are congruent right angles, and we have vertical angles that are congruent here. So these triangles are congruent by angle, angle, similarity. Triangle WXV is similar. I think I said congruent a second ago, but I meant similar. Is congruent to triangle ZXY. Your similarity statements have to have matching corresponding parts. W has to be in the same place as Z. The two angles of X have to be in the same place, and that leaves Y and V to be at the ends. So they're similar by angle, angle, similarity. Okay? And because of the way triangles work, we have some other similarity theorems we can use. This one, SSS, means the same thing it did for congruence, only we're going to put the similarity symbol after it. And that is side, side, side similarity. For side, side, side similarity, remember, similar triangles will not necessarily have the same size, so we don't want to say that all three pairs of sides are congruent to their corresponding sides. We need to remember that in similar triangles, sides are proportional. So here's what we're going to say. If all corresponding sides are proportional, then the triangles are similar. So let's take a look at examples 3 and 4. Now, I've got to give you some numbers for 3 and 4. Now, at any point, if you need to copy this down, you should be familiar with this enough by now to know that you need to pause the video to copy down these diagrams. Okay, so in example 3 here, trying to use side, 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 we have triangle QPR, where I'm giving you all three sides here and all three sides here, having sides 3, 4, and 5, and triangle TSU having sides 6, 8, and 10. To test whether these are similar or not, you have to actually work out these and make sure that they're proportional. So I want to compare side 3 to its corresponding side 6, okay, which would be 1 over 2. And I want to compare side 4 to its corresponding side 8, which is also 1 over 2. And side 5 to its corresponding side 10, which is also 1 over 2. Since these all work out in a 1-to-2 ratio, that means all these ratios are equal, which makes this proportional. Okay, so triangle QPR similar to triangle TSU side, similarity. I'm kind of running out of room. I didn't leave myself a lot of room here. Okay, so we're going to actually skip example 4. We would work that out the same way. But you can skip example 4. We're going to talk about side angle side similarity. As you can see, I ran out of room, so we're going to do a little bit of video recording magic and get this. So our next way to prove that triangles are similar is using side angle side similarity. Okay, it states this. If two corresponding sides are proportional and the included angles are congruent, then the triangles are similar. So we're going to take a look at a couple examples here. In example 5, we have triangle KJL and NMP. And we have these two sides compared to these two. We're going to check that proportion in a minute. But we do have the included angles at K and N marked congruent. Okay? So we're going to check the ratio of 8 to its corresponding side 6, which would be 4/3. And we're going to check 20 to its corresponding side 15. These can both be divided by 5. 20 divided by 5 is 4, 15 divided by 5 is 3, so we get 4/3. That means these sides are proportional to these two, and the included angles are also congruent. So triangle KJ, so it should be a J, L, is similar to triangle NMP by side angle side. We're going to try one more example. Alright, so make sure you pause the video to get this copied down. Okay, these numbers are 25 here, 15, 12, and 21. I want you to make sure that you have this copied down correctly. We're going to show how these triangles are similar by side angle side. Okay? Now, the two triangles are actually ABC and ADE. They both share angle A, so by the reflexive property, angle A is congruent to angle A. But then these sides, marked 15 and 12, should be proportional to 25 and 21. So we want to check those corresponding ratios, 15 to 25. Okay, if I divide both by 5, that's 3/5. Okay, and then I've got 12 to 21. All right. When we try and do 12 divided by 21, they have a common factor of 3, but 12 divided by 3 is 4, 21 divided by 3 is 7. Those are not equal ratios. So these actually are not similar triangles because the sides are not proportional. So our answer is no, or not similar. Okay, didn't mean to trick you on that one, but we do get some examples where they don't work out. The answer is no, or not similar. All right, we're going to try some more examples. All right, we've got 3 examples here of similar triangles, and we want to match it to the correct similarity statement. So let's look at these one at a time. In this, we don't have a lot of information, but we do have congruent angles marked here and here. And remember that vertical angles are also congruent. So I could also mark these two. So I have 2 angles congruent to 2 angles. Okay, so that would be angle-angle similarity. Okay, so we would say these triangles are congruent by angle-angle similarity. Okay? Or sorry, they're similar by angle-angle similarity. I keep using the wrong word. Number 2, we've got these 2 triangles where I've got these sides of 3 and these sides of 4. So you could say that these ratios are both 3 to 4, or 4 to 3. So I have proportional sides here and here. And then there are vertical angles congruent again. Okay, because the ratio of 3 to 4 is the same as the other ratio of 3 to 4. So we have side angle side similarity. And then in our last example, we have all 3 sides given here and all 3 here. We do want to check to see if we have proportional sides for these triangles to be similar. Okay, and these aren't necessarily drawn to scale, so I'm going to check the ratio of corresponding sides. Now, this is the shortest, so it needs to go with the shortest side. So I'm going to say that ratio is 5/2. Then the other side, 10, is in between 5 and 11, so 4 is the one in between 2 and 4.4. So we've got 10/4, which is 5/2 again. And then we have 11/4.4. Now it's hard to see what that one is, and so what we can do is we can multiply both by 10 to get rid of this decimal, and then divide by common factors. Okay, we could divide both of these by a factor of 2. We can work this out, and when you work all of it out, you get the final answer. It actually is 5/2. Okay, we can divide 110 and 44 both by the number 22 and get 5/2. So these are similar by side-side-side similarity. All right, we've got a few more examples here. We want to determine, are these triangles similar? If they are, we want to say how we know, either angle-angle, side-side-side, or side-angle-side. So it doesn't look like we're given a whole lot on A, but these lines mean parallel. So I want you to remember some things about parallel lines. If these lines are parallel, corresponding angles at J and K are congruent. And if these lines are parallel, corresponding angles at L and K are congruent. So I do have angle-angle similarity. Triangle LKM is similar to triangle KJN. So we're trying this out by angle similarity. Okay. Part B, we have an embedded triangle. DST is part of triangle DEF. And we know that both triangles are going to share this angle D, so we do have a pair of angles, so it looks like it might be side, angle, side. So we have to check these proportions of corresponding sides. So DS is 15. That's going to correspond to DE, which is 15 plus 5, or 20. We want to reduce that. 15/20 is 3/4 when we divide it by 5. So I'm going to check this and see if that works. DT, 18, corresponds to the full side, DF, which is 18 plus 6, or 24. Now, the common factor here is a 6. I can divide each by 6, and I also get 3/4. So we do have proportional sides here, here, and here, here, and included angles are congruent. So we can say that triangle DST is similar to triangle DEF by side-angle-side similarity. All right, we're going to check our final set of triangles here, and all that we're given are sides, so I want to match up corresponding parts and see if all of the proportions are the same, all the ratios are the same, making them proportional. So I'm going to check the shortest number compared to the shortest number to start with. That's a good starting point. 16 is the shortest side here, and 22 is the shortest, so I would want to do 16/22. And then I'm going to check the next largest one, which would be 20, to the next largest one, 28, and then finally the largest 25 over the largest 35, and always going in that order, little over big, little over big, little over big. So I'm going to try and simplify those. Now, 16/22 is 8/11, but 25/35 is 5/7, and those are not the same. I don't even have to check the other ones, so I do not have proportional sides. So these are not similar. Okay, and that wraps up our notes. We will do some more examples in class to give you more practice with this, but this has been lesson 3 of Unit 6.